In this problem, we are going to use equations of rectilinear motion to solve for stopping distance. We're not going to call this stopping side distance quite yet. Stopping distance from an initial velocity and given some deceleration rate. So in this problem, what's given is a truck is cruising at 30 miles per hour and the driver spots a road hazard 60 feet ahead of him, and the truck can decelerate 30 feet per second square. And the question is, will the driver be able to stop the truck in time? Let's see how to solve the problem. So the initial speed, which is v1, is 30 miles per hour. Final speed, of course, the truck would have to stop, so therefore final speed is 0. And the acceleration is minus 13 feet per second square. Alternatively, you can call this deceleration without the sign, deceleration of 13 feet per second square, and we are required to find out what will be the distance traveled under these conditions. So as you may recall, there are two equations of rectilinear motion that will come in handy here. The first one is this v2 as a function of v1, a, and t. So v2 equals v1 plus at, and the second equation is distance as a function of initial speed a and t, d equals v1 plus half at square. And if you rewrite the first equation, you will get t, the time it taken from going v1 to v2 using the acceleration a, you will have v2 minus v1 by a. Substituting these values, v2 is 0 and v1 is 30 miles per hour. Of course, we need to be consistent in our units. Converting miles per hour to feet per second, we will have the conversion factor is 1.47 feet per second for each mile per hour. That's the conversion factor, divided by the acceleration rate is minus 13 feet per second square. That's the acceleration rate, or alternatively the deceleration is minus 13. So be careful with the signs when you are entering. So the solution here is 3.4 seconds. So using the second equation, d value is computed using the second equation. So v1 is 30 miles per hour, and we will use the same conversion of 1.47, and half plus half, a value is minus 13. Be careful with the sign again. T square is 3.4 square, and the value you're going to get is 74.8 feet. I mean, the driver only has 60 feet, but you need nearly 75 feet to stop. So the driver won't be able to stop. So there is an alternative way to solve this problem as well. Let's see how to do that. So the alternative way is, there is another equation of rectilinear motion. D is given as a function of final velocity, initial velocity, and acceleration. Of course, here v2 can be higher or lower than v1. A can be acceleration or deceleration, that equation. This is what we learned in physics. For transportation, especially side distance problems, we are only talking about deceleration. For deceleration problems, v1 is always going to be greater than v2. You can rewrite the exact equation as v1 square minus v2 square divided by 2a. And this type of equation is consistent with your AASHTO Green Book notations and notations used in many textbooks. Textbooks. So this is a standard convention used in transportation, so let's use that. V1 square is 30 times conversion factor of 1.47, which is I'm sorry, 1.47 feet per second for every mile per hour. 30 is your mile per hour, whole square minus 0 divided by 2 times 13. Here we are entering acceleration value. Even though this is 13 is a deceleration value, we are entering it as a positive sign, and the answer you're going to get is still the same, 74.8 feet. Of course, the truck is still not going to be able to stop in time. And that's the solution. Thanks for watching.